All right, we're going to do the summation notation for this table now because we need to have a formula so we can do all of this work up here. And the formula always starts off from 1 to n of f of x sub I dx. And now we need to do the parts. So first thing we need to do is figure out what this function is. I'm going to run this function through my summation notation, and the function is 7 minus 0.5 x sub I dx. But we do know what dx is because dx is this change right here. It's this width of 6 divided by the number of rectangles. That should have been squared. So we're getting somewhere now. We have it's the sum from 1 to n of this function, 7 minus 0.5 x sub I squared over 6n. However, I just don't know what this is, but I think I can figure this out here. So it's going to be n of 7 minus 0.5. And what are the x values? Well, the x values are starting... Well, first off, we have it on the sheet right here. The x values are the starting value plus the change. Let me write that down here. X sub I is equal to the starting value plus the change. These are the two formulas that you're going to need to know on this paper. How to find the delta x and how to find the x value. So the x value is the starting value, which would be negative 3 plus the change 6 over n sub I squared 6 over n. And there's our magic formula. That formula right there is going to sum up however many rectangles we want to do through this formula. And you see the formula there, 7 minus 0.5 x squared. 7 minus 0.5 x squared times our dx. All right, so let's see how that works. If I take my calculator and I go to math 0, or if you go all the way down, there's the summation. I'm going to use the letter I, which is right there, hit alpha I, 1, and I want 4 rectangles, so I'm going to put a 4 up there. 7 minus 0.5 parentheses negative 3 plus 6. I divided by the number of rectangles is 4, parentheses, square that, and you can put on your dx outside, 6 divided by 4. And there's our formula. We're summing up 1 to 4 rectangles. There's my formula, 7 minus 5x. I have this crazy thing for x squared times that. Press enter, and there's that number right there, 31.875. Your calculator is going to do all that work. That's a lot of work to do that problem right there. Thankfully, we have the calculator to do it. All right, so now all we have to do is do the same table for 8, 12, 20, 20, 100, and 500. Second, enter, pulls it up. I need to change all the 4s to 8s, and there are 3 of them. So I change that to 8, change that to 8, and I change that to 8. And there's my new number, 32.7. I'm just going to write down the first decimal. You should write down all 3. And now I'm going to do second enter. I'm going to change them all to 12s. If you hit this insert up here, you can't insert, so you don't have to rewrite it all up. Over, insert 12, change the 8 to a 12. I always remember there's 3 places that 12 needs to be inputted. 32.9. And if you see what happens, it's an idea of a limit. We are limiting ourselves to 33. We're getting closer and closer to 33. All right, let's change that to 20. 20. There's always 3 places. 20. 33.0. All right, now let's do 100 rectangles. Change this to 100. Change this to 100. change the number of rectangles to 100. 33 again, a little bit closer version of 33. All right, we're getting very close. Let's change that to 500 rectangles. Now there's a mathematical way to do this. That is an extreme amount of work. Thankfully we have a calculator that will do it for us. 500 rectangles, 32.999, 33. So see what's happening? Actually, maybe I should just write this, 32.999. Look how close we are getting to 33. We're getting closer and closer and closer to 33. And that's the goal on there. All right, how do you do infinity? Well, we've already done infinity. Infinity is what the calculator did for you. I'll show you another way to do infinity. If you hit math, number 9, your calculator has an integral formula on there where you just put -3 to 3. You can type in the formula itself, 0 minus 0.5x squared dx, and there's your 33. So what have we done? We have drawn a curve. We found the area. Area is 33. We have found the area graphically here. We have found the area numerically here. We have found the area analytically here. That is 3 different ways. 3 different ways to answer one question. What is this area? Analytically, graphically, and numerically. Answer is 33. All right, I hope this helps.